Hey guys, what's up? How are you doing? You know what? It took me some 2 to 3 days to get back to work here, but thank God I'm back, and I'm back with the next topic, and that is again from the biomolecules. But I must remind before I even let you do that. So far, what we had done in the biomolecule was about glucose, fructose, biomolecules classification, carbohydrates, Howard structure, mutarotation, and there's so many things we have done, right? Now, what today I'm talking, that is very, interesting, but it has a bit something, that you might have, seen it in the past, and that's about, some reactions of the glucose and fructose. So let me tell you what topic is today. I'm going to talk about the common reactions that glucose and fructose exhibit, right? And these reactions are Tollin test, Fehling test, and there is another one. It's called Benedict solution test. Now, two of them I have already done, that Fehling test and the Tollin test in the aldehyde one, right? In case you haven't watched it, I must tell you, you go back, after you have watched it, or before, even you come back here, you must watch that, because that silver mirror test or Tollin test was one very important topic. You cannot ignore it at all. So that was one of the most important topic from the aldehyde, from the organic chemistry section, right? So today we have, to talk about all the reactions. Basically, it's going to be 2 to 3 reactions that both glucose and fructose exhibit. So the topic is, let me repeat back. I'm talking about the reactions that both glucose and fructose exhibit. So this is about the common reaction that both of these, carbohydrates exhibit, right? So let's start that and see what this is. Let me tell you before I proceed. Again, this is going to be a short lecture, right? So we have a couple of reactions through which we'll be doing everything. Now, what we need to do, suppose we are talking about glucose. So what is glucose here? C6H12O6, right? Now, this is the formula, but what you do know is that the structure of the glucose, you probably, remember almost everything. That first carbon was in the form of, aldehyde. Then the second carbon was something like this, with H on the left hand side. The third one has a hydrogen on the right hand side, while OH on the left hand side, and rest of all the hydrogen, whatever the number of hydrogen carbons are remaining, they had OH on the right hand side. So this is what your glucose structure looks like to be. This last one is again, achiral, and this was in the form of CH2OH, right? So there you have an H, there you have an H here. So this is the open structure of the glucose. I hope you remember each and everything about. There's so many things we have done so far. Now, this glucose, or you talk about the fructose. So let me write, the fructose structure as well. The first one is in the form of CH2OH. Then your second one is in the form of a ketone. The third one has no change. It's going to be H, and on the left hand side going to be OH. Remaining carbon has OH on the right hand side, just like the glucose, while hydrogen on the left hand side. So this is the structure of the fructose coming out to be. And the last one, again, this was about, CH2OH. So this is the structure of the fructose. Let me write. This is your C6H12O6, and I'm talking about the fructose. I'm talking about fructose here. And this is about, your glucose. So this is glucose structure, and this is your fructose structure. Now, what we have common, with these two carbohydrates, with these two monosaccharides, is that both of them, let me tell you. So this is like, these are not reactant. I'm taking them, as a reaction here. So these are, reaction as a common here. This is the way I can represent. If you don't find it, good enough, you can make separate for them. So what happened? Either of them, when react with, Tollin reagent, just pay attention. Tollin reagent. I'll write you the formula, but let me write a bit of that. Tollens reagent. Now, what was the tollens reagent here? It was actually silver. It was actually ammoniated silver nitrate, right? But I'm not going back too much about this topic. You can go and check out. There's so much about this topic in the aldehyde section. So Ag, and there is ammonia, and this is a coordination compound with a positive charge. So what is happening here? Either glucose or the fructose went with this tollen reagent. What happened? To pay attention here. Since this is a mild oxidizing agent, let me write here again. This is a mild oxidizing agent. You have to pay attention, very important this is. So this is a mild oxidizing agent. So what will happen? The aldehyde will oxidize into carboxylate. This aldehyde will oxidize into carboxylate, right? Wait, but you might have a question that there, is ketone here. There was aldehyde, so it can oxidize into carboxylate. But there is ketone, and a ketone is not oxidized by mild oxidizing agent like tollen reagent. So why this is happening? Actually, this is not oxidizing. Actually, this 1 degree alcohol will oxidize, and this will convert into a carboxylate anion. So let me write this. There, this carbon 1, and there, again the phos carbon here. These two carbon undergo oxidation that they both form carboxylate anion. Carboxylate anion. So carboxylate anion is the form here. What did it mean? That phos carbon convert into C double O negative. Let me repeat back. There is not enough space, so I'm not writing both of these product as. So what I will do actually, this very phos carbon I will convert into a carboxylate, and again this phos will also convert into a carboxylate. So let me simplify this in the form of a very short reaction where you can get exactly what is happening with the glucose and fructose when they react with the tollen reagent, right? Now just pay attention how this reaction looks like to be. You know what? In the glucose, what I'm going to do, I'm placing that phos carbon in the form of a aldehyde, right? This is your aldehyde, and remaining I keep this as a R. I keep this as an R. So this represent to glucose here. This represent to glucose, right? And then what you are doing, you are reacting with silver, ammoniated silver nitrate, tollen reagent, and that is your Ag, NH3 whole twice, that comes out as a coordination 1 with a positive charge. And what happened? This is a mild oxidizing agent. You have to pay attention. This is a mild oxidizing agent. Because this is a mild oxidizing agent, this aldehyde will convert into a carboxylate. So this goes like C, this goes like C, and again a carboxylate anion, and rest of the things there is no change taking place here, right? So this become a carboxylate. Now the question is, there is no aldehyde in the fructose. So why the same reaction happens to be there? Let me explain you. See, the thing is that I'm taking this one as CH2OH, and this next one has a keto group, and remaining I'm placing this as R. So what happened when you react this? With the tollen reagent, AgNH3 whole twice, and plus 1. So remember, this is the cuprous ion, and then what happened? This converts into an aldehyde. So what I'm doing, I'm converting this first one as an aldehyde, and there you have your ketone. There is no change taking place, and rest of the thing I'm placing as R. Now this again react with, pay attention, this again react with the tollen reagent. And what happened? This one converts into a carboxylate. C double bond O with the negative. Down here you have ketone. There is nothing changing here. And again you have rest of the thing as usual. So what that mean here is that a glucose, first carbon is in the form of aldehyde. So when it reacts with toluene reagent, it directly converts into carboxylate anion. Similarly, the fructose, which has a ketone group on the second position, it does not undergo any reaction because ketones are not oxidized by a mild oxidizing agent like toluene's one. But in the ketone, you have your first carbon, as primary alcohol. So this alcohol oxidizes by this mild oxidizing agent and it converts into aldehyde. But in the next reaction, this aldehyde convert into carboxylate. But along with that, what you also get, you get Ag, right? Similarly, here you will get Ag as well. So this is how I would, conclude this right here, is that both glucose and fructose exhibit positive result with the toluene test, toluene reagent. The difference is that glucose directly convert into carboxylate, right? But fructose first convert into aldehyde, first carbon, and then the aldehyde further react with the toluene reagent and then it converts into carboxylate, right? While silver undergo reduction in both of the cases where this one looks like a silver mirror. So this is one of a very important, chemical reaction that both glucose and fructose exhibit, in a similar manner. And tell you one thing, very important one. This is one of the reason why glucose and fructose, these are called reducing sugar, right? Because they have reduced this oxidizing agent. Both are reducing, both are reducing this oxidizing agent, and this oxidizing agent is oxidizing both glucose and fructose. Let me write this. This one is your fructose. I haven't mentioned here. So I'm just mentioning. So they both, both glucose and fructose respond to the toluene reagent in a similar manner. So I should, wind this lecture right here. Why? Because I have already taken way more than 15 minutes. So I will do another reaction or probably 2 more reactions in the next lecture. I will say thanks for watching. Don't forget to come back because these are really something important, right? Take care and good night.